Hello, Assalamu alaikum. My name is Mohammad Tasbiruddin. My ID is 224998663. Today I am presenting Smart Park Automated Parking Control System. At first, the project introduction. The main goal of this project is to automatically control and monitor the parking spaces. The system shows whether the parking area is full or the space is available. It reduces the human effort and helps the drivers know parking availability easily. The capacity and logic and calculation which are taken by the student ID of mine, at we have taken all of my the number of my student ID at A B C, all of the alphabets. The parking available space is we got 13. System block diagram and component flow. The system works using several blocks. First, the keypad is used to input maximum capacity. The encoder converts it into binary. Register A stores the maximum capacity. Entry and exit sensors detect cars. The up down counter counts the cars. The register B stores the current number of cars. The comparator compares the register A and B. Finally, the 555 timer controls the display. For this project, we use the hardware that were used was 74LS192N, which is a 4-bit up-down counter for counting vehicles, and along with 74LS85 comparator for comparing capacity and current cars, 555 timer for generating pulses. IR sensors are used to detect car entry and exits. Pulse generation and display logic. The 555 timer is used to control the blinking of the display. The high time TH is 4 milliseconds and low time TL is 4 milliseconds. When the current car are equal to maximum capacity, the display shows full. Or else when the car are less than maximum capacity, the display blinks space available. System operational flow. First, the system starts, then it reads the capacity and store it in register A. The sensor detects the car that are entry or and exit. The counter increases for entry and decreases for exit. Register B stores the current car count. The comparator check register A and B. Finally, the display shows full or space available. The process repeats continuously. The 555 timer calculation. In this slide, duty cycle, frequency and time period of the 555 timer are calculated. This calculation ensures the correct blinking of the display. This makes the output clear and visible to users. FSM design, timing behavior and state transition. A finite state machine is designed to generate two outputs, A and B. The clock period is 1 milliseconds and output A stays high for 4 milliseconds and output B stays high for 4 milliseconds. This ensures proper timing behavior for blinking control. At that table, we see in this table they state S0 to S3 to give A equal 1 and B equal 0. The state S4 to S7 give A equal 0 and B equals 1. The FSM works in a cyclic manner to generate blinking signal. Like all projects, there are also some limitation at this also. This system has some limitation. The 4-bit counter can count only up to 15 cars. The 555 timer has no enable control internally. The sensor may give false trigger due to noise. The capacity is fixed and not used not user friendly. For the modification for large scale and implementation, for large parking systems, some improvements are needed. We can cascade multiple counters for higher capacity. We can use 8-bit or 12-bit registers and comparator. LCD or LED matrix displays can show detailed information. A microcontroller or FPGA can also be used for better control. At conclusion, this project is successfully shows parking status using digital logic component. It is suitable for small parking areas, not larger. With some modification, it can be used for large scale parking system. Thank you.